Hello guys, welcome back to mathematics class with me, Ma'am Ruth. Today we will continue our lesson about trigonometric function, and this is the fourth part. In today's lesson, the lesson objectives will be: first one, recalling all trigonometric identities; the second one, deriving Pythagorean trigonometric identity; and the third one, solving trigonometric identity. So, what is identity? Anybody know about this? In mathematics, trigonometric identities are equalities that involve trigonometric function and are true for every value of the occurring variables where both sides of the equality are defined. So, it is similar with equalities, and we will see later to make it clear. The first one, we will review all trigonometric identities that actually we already have before this lesson today. The first one is the identity of reciprocals. So, with the relation of reciprocal, we have cosecant alpha, which is equal to 1 over sine alpha, secant alpha, which is 1 over cos alpha, and cotangent alpha, which is 1 over tangent alpha. We also have the ratio identity. Do you know what ratio identity is? This is what we have. We have tangent alpha, which is sine alpha over cos alpha, and since the reciprocal of tangent is cotangent, we have also the cotangent alpha ratio, which is cos alpha over sine alpha. The last one that we already have is the complementary identity. In complementary identity, we have cos alpha, which is sine 90 minus alpha. If you forget about this formula, whenever you need, you can build up the right angle triangle and see the relation between opposite, adjacent, and hypotenuse side. We have cosecant alpha, which is secant 90 minus alpha. Can you see the co-ratio at the left side? Cosine for the complementary of sine, cosecant for the complementary of secant, and you can guess what is the last one, right? The complementary of tangent, which is cotangent. Cotangent alpha is tangent 90 minus alpha. Next, since we already have some identities before this lesson, now we also will derive the Pythagorean identity. Since we know in unit circle that the relation between adjacent and opposite side is x squared plus y squared, which is the same with the radius, and the radius in unit circle is 1, then you also can change it into the trigonometric ratio. Can you still remember that x value in the unit circle is in relation with the cos alpha and y, which is sine alpha? So now we can write it in the trigonometric ratio that cos square alpha plus sine square alpha equals 1. Then, with this identity, we can have some formula ahead. The first one, if you divide this identity with cos square alpha, for which cos alpha is not 0, then we will have cos square alpha divided by cos square alpha, which is 1, plus sine square alpha divided by cos square alpha, which is tangent square alpha, and 1, which is divided by cos square alpha, becomes secant square alpha. Next, when you need the identity in the terms of tangent square alpha, then you can make tangent square alpha equals secant square alpha minus 1. Next, let's divide this cos square alpha plus sine square alpha equals 1 with sine square alpha. The same here, don't make sine alpha equal 0 because it will be divided by undefined value. Cos square alpha divided by sine square alpha become cotangent square alpha. Sine square alpha divided by sine square alpha equals 1. And 1 divided by sine square alpha become cosecant square alpha. Same here, we can make cotangent square alpha equals cosecant square alpha minus 1 if you need the formula for cotangent square alpha. So, with this all identity, later we will have to prove this identity. So, we have some terms in the left hand side and we have to prove it equal the terms in the right hand side. So in the proving, we have to assume first that it is maybe not true. So to prove it to be true, we will write down. If you want to write it down, you will write it in RTP code, which is the symbol for required to be proved equalities. So later, you can choose which you want to start, whether it is from left hand side or from the right hand side. So usually, you will choose the complex one and you will simplify into the right hand side as it is tangent theta here. So here I will write down LHS, the symbol for the left hand side that you are taking, and this is written as cotangent theta secant square theta minus 1. And then later we will change it become tangent theta by our identities that we have. Cotangent theta multiply with secant square theta minus 1, you can change secant square theta minus 1 become tangent square theta. And then you will use the reciprocal identity cotangent theta, which is 1 over tangent theta, and multiply with tangent square theta, so it is become tangent theta. And you are finished in proving the right hand side. The second proof, here we have 1 over 1 plus sine theta plus 1 over 1 minus sine theta equal to secant square theta. So here, if you want to write it down, don't forget the symbol of RTP, required to be proved. Then, now you will choose which side you will start from. Here, I also start from the left hand side. 1 over 1 plus sine theta plus 1 over 1 minus sine theta. So, what step do you think needed here to make it become one term only? So, since here this is two fractions, you can combine them become one with the denominator which is common. So, we make it the same denominator. Here we have a plus b. Multiply with a minus b, which result 1 minus b square or 1 minus sine square theta here. And then cross multiply to get 1 minus sine and 1 plus sine. And then you can have sine theta is dismissed and you have 1 plus 1 as 2. After that, at the denominator you can simplify using identity formula 1 minus sine square theta, which is cos square theta. After that, you can have the reciprocal of 1 over cos, which is secant, and square it. So you have 2 secant square theta at the end, and that is your right hand side term. So that's how you prove some identities. And let's have another example and get more exercise to master this kind of problem. That's all for today. Let's meet again later and see you soon. Bye bye.